Hello, I'm back, Mr. Angus Wangus, for another video. I've been working out in the yard, and like I mentioned in the last video, and I've been tired in the evenings, but today it's raining. It's only like 7:30 in the morning, so I'm still trying to get coffee in me too. So hopefully this goes well. Hopefully this will just be short. I'm going to edit a couple videos together. Basically, same setup. I haven't touched the input or anything like that. Amps going into the little motor. This wheel's being driven on that shaft by a little DC motor. Just showing to because there are new people watching and ask. And there's a little motor controller here, and it's running off a 12-volt battery. So that's the prime mover. Excuse me. And it's pulling about a 1/4 amp. And here's the voltage on the battery. I also have an AC meter like last time hooked up, and I just have it hooked to this one coil. Now they're both same as last time. I haven't taken it apart yet. I haven't touched it since. But these two coils are wound in the same direction on this core, just like the last video. But I wanted to show just the one coil. This coil is open circuit. There's no connections made to it at all. This one has a switch on it, which is open right now. It's an open circuit, giving about 12 volts. Let's look at the RPM. Oops. $582. 582. So it's still on this core here. So we're communicating with both sides of the magnet still. So it'll be interesting to see what happens. So I'm going to flip the switch on this coil. I predict that the same thing's going to happen. I predict it's going to speed up. Someone had asked, what if just put a coil on here or put another coil on here? But I can hear it speeding up. I can see the input has dropped a bit. It's shorted out. And it has. It's sped up. And someone suggested pinning this thing down. To check the RPMs. So it's sped up to 650-ish. 650. So it did. It sped up. So I just shorted this one coil out on this core, U core, and the wheel sped up. So what I'm going to do now is I'm going to take this off, and I'm going to put just one core on there so that I'm not communicating with both sides of the magnet on one side, and I'm going to have one coil on it, and we'll see what happens. And I predict it should give a regular lensing effect. Actually, what I'm going to do is I'm going to put two of these on here, and I'm going to show one coil on communicating with one side, and then you'll see. Anyways, here we go. And I'll be back, right back. Okay, back for part 2 here. I haven't touched the input or anything. Yeah, basically the same setup. This is the input to that little DC motor. First thing you'll notice is that the input is closer to the input that it was when I had the U-shaped PMH on here and with the coil shorted, right? So we'll have a look at the RPMs, and sure enough, it's closer to that shorted speed that we had in the previous part, right? Now there's much less, or much less attraction flowing here now. with the continuation of the core in the U shape, it was continuous, right? And we had both sides of the magnet communicating there. So now what I've done is I have this coil open, right? It's open circuit. These two leads are just sitting here. This coil, again, I have on a switch with an AC multimeter, and we'll see what happens here. Let's just have a look at the RPMs one last time. 630. 630. Let's flip the switch. There we go. We're shorted. This one coil is shorted. This one is still open, right? And we'll see what's happening. I see the input is going up already. That tells me the wheel's slowing down probably. Oop. And it is. 604, 603. This is 602. So the speed of the wheel is dropping with this coil shorted, with communication of the core just to one side of the magnet. So this is a regular lensing type effect, right? So we're shorted. The input to the motor has gone up because it's having to work harder, right? And this is the way a normal generator works, right? And the speed of the wheel is dropping due to the lens, the opposing lens force. There's a magnetic field created by this coil being shorted out, and it works to retard the speed of the generator wheel, right? This is conventional electric generation concepts, right? Now what I'm going to do is we'll go to part 3, and what I want to show is this coil. And these two coils again are wound in the same direction, right? I have the two clockwise coils over here. These are both the counterclockwise coils. This is the start and finish of this coil, and this is the start and finish of this coil. So they're in series, right? If this was a U. And what I'm going to do is wire them in series, just like with the U. And we'll see what happens. We'll see if we get a normal lensing reaction. I already know I'm not, but I'm going to show it. If you've been following my videos, you've seen this arrangement before. But anyways, there we go. Part 3 coming up. Oh, sorry. Just want to point out, we're getting a regular lensing type effect on the wheel, right? With this coil being shorted. It's not speeding the wheel up, right? I had the U shape with one coil on it, shorted in the first segment of this video, and the wheel sped up, right? With this arrangement, the wheel is slowing down. It's more of a normal arrangement with lensing, the lens effect. But what this also shows is that this coil actually is of a low impedance. Someone had asked and mentioned in the last video about the impedance, and you're completely right about that. And I was aware of the difference between AC and DC resistance and impedance, right? You need to factor in the power factor with AC. But I just wanted to point out that this little test right here with this one coil shorted on the one core on one side of the magnet with the wheel slowing also shows that this coil is of low impedance actually. I don't have an impedance meter per se, and I'm not into doing the exact calculations, right? Sit down and do that. I'm testing the effect right now, generally. So, but what this shows is that that was a good estimation, that this is low impedance. If this was a high impedance coil and I might get a delayed lens type effect, right? Delayed lens, I think, is different than what I'm seeing here, right? Because, and not to mention, in past videos, I've done this with 16 gauge wire and got the same effect, right? Which is very heavy. I think that actually might be more like 14 or 12. Anyways, there you go. Just wanted to point that out. And thanks to everyone for the question or comments and suggestions and where this is leading in our thinking, because, you know, I'm just a caveman, biologist actually. So, you know, I don't know everything for sure, but we're learning. Okay, so the next segment is going to be these coils wired in series like I had with the U-core, and we'll see what happens. All right. Part 3. Okay. Same thing. Same arrangement as the previous video with the U-core. So this is the start of this coil. They're both wound in the same direction. This is the start of this winding. This is the finish. It's wired in series with the start of this winding. Again, wound in the same direction. And this is the finish, and it's coming. The start here and the finish here are through a switch, which is open right now. And they're in series, so it's giving me double the voltage, right? And I'm going to be getting into output and input testing. I just really had to show this. These tests have been long overdue, but again, I've been waiting until I had 4 identical coils, 2 wound in the same direction, to be able to do this, because otherwise the findings would be inconclusive with the other wire arrangements I had going on. Look at my mess. My mission for this afternoon is to clean that up a bit too. So, and my next move is to go with the Kromrey arrangement, right, on 2 U-cores. But anyways, wanted to show you this. So these coils are in series. They're wound in the same direction. They're in series with respect to their poles, start, finish, start, finish. They're wired in series electrically. I have a switch which is open right now. It's giving this much voltage. We see that the input to the motor again is close to this shorted speed that I showed with the U-core. And then the last clip we saw the wheel slow down with lensing when I shorted just one coil on one side of the magnet on a solitary core. Now we're going to see what this does. These cores are separated, right? There's no U. Honestly, I haven't done these tests. I just woke up this morning having to make this video. So, but we'll see what happens here. So we have a speed again of somewhere near 630. 630-ish, 627, 628. So what I'm going to do is close the switch. It's shorted through the switch. Well, input's increasing a little bit. Yes, and the wheel is slowing. Oops. And so it seems to be, I got to take that advice with clamping this meter down to do this. Okay, so it's slowing down even more, right? With them in series. And so now And there's more energy flowing through those coils over those cores. There we go. All the way down to 570 now. Input's gone up to the little motor. Still shorted. Okay, so one more segment. Now that we see that yes, it did slow down, right? Now it's lensing on the wheel as it is right now. Whereas with the U-core, with this exact same arrangement, it released that wheel, made it go faster, right? Now, interestingly, I think, if I can show it, I won't go there. So it's down to 573-ish. So what I'm going to do now is, seeing that it slowed down, gave us a regular lensing effect like this, with the core, with this exact same arrangement as with the U-core. I'm going to do one more segment, and I'm going to wire these in parallel and see what happens. Okay, hang on. Okay, final segment. I hope this doesn't turn out too long when I edit it together. So same arrangement, same input, amps, volts, same core arrangement. They're divided. Now I have them in parallel. Last segment I had them in series wired. Now they're in parallel, but you might notice that in order to parallel them up, now I had them in series before, this end connected. If I connected this end, it would have been shorted, right? So in order to parallel them up, I have to bring this connect terminal together, and this terminal, and this terminal, and this terminal, and that gives me the two terminals connected to the switch, right, which is open right now. It's giving me 12 volts. Let's check the RPM. Again, we're near that 630 mark. .630. Yeah, there we go. So now we'll see what happens, and we'll flip the switch. Again, they're in parallel. Last time we had a slowing of the wheel with the coils in series. With this core arrangement, the wheel slowed, and it sounds like it's slowing. Oh, the input's going up a bit. It must be. And it seems to be slowing just like the previous segment. Down to 585 already. Shorted out, wheel slowing down, more of a regular lensing type effect. But you see that with the other arrangement, with the U-core, we can use the electricity, short it out. Full load is what this system likes, right? And also, just to mention, with the U-core, there's a fair amount of attraction, right? As opposed to here. I think it was going 550 with the U-core, with this input. Now, when we use the electricity, it speeds up to 650. I forget what the number was. You know, which is where we're starting out with this arrangement and then slowing down as we use the energy. Just as in a normal lensing generator type system. So what this all tells me, shows me, or suggests to me, and again, I'm no expert, is that U-core is vital. Vital. Not so much the direction of the windings, right, as I was led to believe earlier in my videos and experiments. I'm seeing now that you can have two coils wound in the same direction in series with respect to the poles on a U-core and get the good effect, right? Very interesting. And again, with the slowing of the wheel, this shows that it's not a delayed lens type effect. The frequency here is low. The impedance here is low. But there's something different going on here. And it has to do from these tests, it shows it has to do with that magnetism flowing from both sides of that magnet through the core. The B field in that core is critical for getting the effect. There you go. Well, I'm going to wrap it up, and the rain has stopped, so it's still early, so I'll probably sneak outside. But next direction is to continue with that Kromrey arrangement. 2 in the same direction and 2 in the opposite direction on another core with opposite polarities passing the cores at the same time. Should be interesting. But there you go. Oh, and one last thing I wanted to say is, in the last video I mentioned, someone was asking about what I meant with this in respect to just not having any lensing, just not even having the wheel speed up or slow down when you use the electricity is a good thing. And this makes Overunity possible in my eyes because we already can make machines, and there's lots of them on YouTube, lots of great videos and guys doing stuff out there. But there's lots of examples of machines that are, you know, very, very, very efficient, just using a normal, conventional understanding of electricity, right? We can make a system that is 90 whatever % efficient. So if we can find a way to make it just a little better, we're going to go Overunity sooner or later, and I think it's going to happen, right? But lots more to do, lots to test here. Still at it, and hopefully that happens one day. But still at it and still working at it. Just wanted to point that out. Again, tell me what you think's going on, and it's those opposing vortices interacting, it seems to me. It doesn't seem to be a delayed lens effect, right? Which I didn't think to begin with, right? But it's not so much the direction of those windings that's critical, it's that communication of both poles of a magnet that seems critical. There you go. Probably going to end up being a long-winded one, sorry. Hopefully I'll have the energy later this evening to, because I think I'm going outside now. But I hope I have the energy to go at it more. I should, but I'll have my yard work done soon. Anyways, there you go. Lots of fun. Tell me what you think. I'll talk to you later.